and thanks for tuning into our podcast series entitled Farming of the Future. You're here with Laura Sisman
and Ben Genda.
So today, we will be discussing the global food crisis, because after all, who doesn't love food?
Experience. Incredible.
There are many seeds of thought, pun intended, when it comes to how we're going to feed the growing population in, say, 50 years. According to the Pew Research Center, it is expected that by 2050, the population will be at 9.6 billion. Africa's population is projected to increase the most and make up a greater share of the global population by 2050.
This astounding number, combined with growing concerns for food sources, has led scientists, engineers, and policymakers alike to brainstorm solutions. These solutions can be social, such as greater access to education or government aid, or technical, like urban farming. On today's podcast, we will be discussing and analyzing the socio-technical implications of two such technical solutions to the global food crisis: vertical farming and genetically modifying foods. The term socio-technical, in this case, pertains to the interplay between technology and society.
So what is vertical farming, first off? Imagine a skyscraper with a glass facade filled with trees, shrubs, and plants, and fruit. It sounds almost like a form of a sci-fi novel, right? Despite the sci-fi-esque feeling of a green skyscraper, the history of vertical farming is rather developed. The first drawing of a vertical homestead, as it was called in Life magazine, was in 1909. The drawings are black and white, etched in pencil, and they look like long strips of houses stacked on top of each other on platforms. Merely 6 years later, the phrase vertical farming was coined by Gilbert Ellis Bailey, a professor of geology, in his nearly forgotten book called Vertical Farming, where he defined the earliest meanings and methods of vertical farming. He recognized the need to find a solution for the crisis of food insecurity as early as 1915. And then, at the turn of the 21st century, where we lie now, Dixon Despomier publicized and reignited this idea of vertical farming. As there are always two sides to any story, there are opposing opinions to vertical farms. The common denominator between all opposition is that operating a vertical farm would require a very large carbon footprint. Energy is required to transport the fluids like irrigation, to keep the temperature mild inside the actual building, and to operate the plant lights. Renewable fuels are being researched, but these are under government scrutiny before they can be commercialized, such as the use of algal biofuel. Factors that aren't taken into account also include land use policies and regulations with vertical farming. So how does zoning change when you've got a farm that's in the area that a skyscraper would take? Further, would multiple farmers rent one skyscraper? What if the giant agribusinesses, such as Cargill, that exert enormous market control and political influence, don't support the vertical farm? Money and government support stand in the way of commercialization of vertical farms. Despite these challenges, though, Google's director of engineering predicts that vertical farms will be standard by 2030, only 15 years from now.
So what exactly are genetically modified foods? They are simply foods or food derivatives that have had their DNA altered intentionally, allowing new beneficial characteristics to arise. This allows humans to have more control over the food they produce, particularly in cash crops such as soybeans or corn. This usually involves altering or adding genes to a plant's genome in order to acquire a certain trait. So when did humans first start modifying food at the microscale? The International Food Council explains how it was first seen in the ancient Babylonians, who were able to use microbes like yeast to ferment beverages. This modified the food at the microscale in order to develop a completely different type of beverage, beer. The same concept applies with genetically modified foods, except you now alter foods at the biological level. Since then, the invention of the microscope and the work of Louis Pasteur has given humans the ability to modify a plant's blueprint all the way down to its DNA. Commercialization of this technology did not begin until the 1990s, when produce companies were able to market super vegetables, such as the delayed ripening tomato, or corn resistant to insects. With the commercialization of this technology, many socio-technical issues arose. While this technology has increased food yield and human health significantly, humans are scared of the unknown. The unknown includes these new technologies that could cause our demise. Not only is the public concerned that these foods that have been genetically genetically modified are harmful to our health, but there are also many political, ethical, and economic controversies associated with genetically modified foods, as is with vertical farming. There is a social stigma that eating these GMOs is going to kill us, but the real issues are gene diversity, the politics surrounding genetically modified foods, and the ethics regarding our right to manipulate DNA. Many people look back at the Great Irish Potato Famine, for example, where an infectious organism killed most of Ireland's food source due to lack of diversity, also known as monoculture. And it scares us because we face a similar decrease in food gene diversity when we genetically modify crops. Genetically modified foods creates a very real issue of this monoculture, where a constricted range of genetic variation within a crop's DNA will cause a crop to go extinct. In essence, it is dangerous to put all our agricultural eggs in one basket. So, the big question, do genetically modified foods harm the human body? There has been no study done that shows that these genetically modified foods are harmful to the human body. Conversely, many studies show that these modifications are more harmful to the crop itself and the ecosystem it exists within. This all comes back to the danger of monoculture I already discussed within a crop and an ecosystem. This ties into the ethical dilemma of whether or not humans have the right or maturity to modified plants, all the way down to its DNA, when there are so many potential consequences to be discovered. Finally, an issue shared between vertical farming and GMOs is the power struggle between economics and politics. Both of these technologies are shaped by the political and economic climates that surround them, thus shaping the trajectory of what they will look like in the future. For example, many corporations such as Monsanto claim intellectual property rights to certain GMOs. As the world becomes more crowded, these technologies will become part of a global power struggle. Many questions regarding these technologies remain unanswered, and unfortunately, solving the global food crisis oftentimes isn't the main concern. Politics and profit many times is. Possibly the most important question we should be asking is whether or not the government should regulate these two technologies more closely.
Vertical farming, in conclusion, finds a solution of feeding an increasing population by cultivating upwards and changing the environment in which crops grow. GMOs, on the other hand, find the solution of feeding an increasing population by changing the anatomy of how plants grow.
As technology seems to accelerate at an unstoppable pace, it is our responsibility as humans to pursue the marriage between revolution and preservation when pursuing new agricultural technologies. Thank you for listening, and see you next time on another episode of Farming of the Future.
This program was made possible by contributions to your UVA station from listeners like you. Thank you.